The first one that I'm going to put on the list of underrated, underused technologies is Strace. Strace is a system call tracing utility. You can invoke it a couple different ways. One is you can just strace as a wrapper for another command. And so what we can see is that here, as an example, the command wrote out some output, but here is all the stuff that that command did. And each line is a system call the command made with that were passed to that system call. So strace is underutilized because most people look at that giant pile of stuff that comes out of it and they're like, whoa, don't know what to do about that. But here's the thing. If you want to go down the rabbit hole and learn a ton, an absolute ton about how things work on Linux, strace is your jam. Let's take a quick look at a slightly smaller thing. I'm just going to pipe, how do we do this? I'll send it to a file. Oh, maybe I send standard output to a file. There we go. So strace sends its stuff to standard error because I had to redirect standard error to this file. And what we're looking at is all the stuff that ls is doing once it's invoked. So we'd see a call to exec this executable file. And then this call for mmap. It turns out all these system calls are documented. So if I do a man on mmap files and devices into memory. And then the description. mmap creates new mapping in the virtual address space of the calling process. And then it tells more details about how the actual memory mapping is accomplished using this system call. All right, we execute the command. It starts to map memory for itself in its virtual address space. Open AT. What's that do? Open AT. This is to open or create a file. If we go down to the description, the open system call opens the file specified in the path name.
That's weird.
I know, it's how this works. So it opens this etc configuration file. fstat, probably something like file status. In the brief description, it said get file status. These functions return information about a file in the buffer pointed to by statbuf. No permissions are required on the file itself, but in the case of fstat and lstat, permission is required on all the directories in the path that allow you to access the file. And then it tells you a little bit more about what these do. So fstat is identical to stat, except the file about which information is to be retrieved is specified by the file descriptor. Right? We can see that it returns things like the permissions that were on the file and the size of the file. As you can guess, read is reading the contents of something. Then we do some more memory mapping. Then we close an open file. Then we open another command and read it, get its file status, and then we map some data out of that file, and then we close it. So this is what we're looking at when we look at a strace of a command, right? If a command is not behaving the way you expect, it's not providing the output you expect, or it's producing an error, you can actually use strace to actually go through and trace like all the things that command is doing, maybe down to where it failed. In the case of errors, down here at the bottom of the strace, where you see that exit, around in there is where you would see the error messages and other stuff that happened. You just look up a little bit from that to figure out what it was doing when it encountered that error. strace is super handy for figuring out what something is doing. There are a couple other ways that you can use strace. So we can use strace-c. So strace-c does is it counts these different system calls. And it reports on how long it took doing these system calls and what percentage of the overall time was spent in these system calls. We can see that this ls that I ran, almost 23% of the time of it was running, it was actually calling mmap to map memory. And 22% of the time, it was opening files. And 12% of the time, it was getting the status of the different files it was working with. And 11% of the time, it was closing the file handles that it had opened. This is a really useful tool measuring where your program is spending its time. If something's taking a lot of time, it's spending a lot of time on this weird system call that you're not expecting. Maybe that's where you should focus your efforts. So you go and man the system call and figure out what it's trying to do, and that can indicate where your problem lies on your application. Also, the number of calls, that's the fourth column. If you see that one call is being done over and over again, maybe that's where your problem is. Maybe you should figure out what that means and what the application is doing in that state. All right, there's another way that we can use strace though. strace-p. And actually, before I do that, let me find a process that I want to attach it to.
I was just going to ask if you could view an existing process, and here you are.
Exactly. I'm trying to pick one that's not going to overwhelm us with data.
Yeah, I saw our syslog up there. That'll probably give you some interesting output.
So when I was writing
underneath
the episode, I found a couple. You
shouldn't be using the one you planned on using, because that's not how Into the Terminal works.
We just go off script and like, who knows what happens?
See what happens.
Oh, yeah, no. There we go. That's what I want to do. So process 871 is tuned. All right, so tuned is a daemon that will change your performance profile, and it'll go through and set different things in procsys and /sys for determining IO scheduler and customizations to it, or memory settings, or what have you. So when I attach strace to it, by specifying its process ID number, we're watching what it's doing in system calls live right now, right? And you can see that it's doing the same thing, just over and over again, futex. All right, well, just like before, what does that mean? So I'm going to hit Control-C to detach off of that process, and I'm going to man futex. All right, so futex is fast user space locking. That's not overly descriptive. The futex system call provides a method for waiting until a certain condition becomes true. We know that daemons run all the time, only do something when there's something to do. And futex is a way that we can tell the daemon through setting some shared memory stuff that there's something for it to do. And so the reason that it's just sitting there banging on is because it's checking the shared memory register. It's checking the shared memory register to see if something has changed that tells it to wake up and do something. So that's why it's just kind of in this endless loop of. Another option would be, let me start up HTTPD. And so if I attach to this root-owned HTTPD, this is what my Apache web server is doing. We're watching it live, right? We can see that it woke up and checked a socket. It actually connected to the network. It sent a message. It's waiting again. It checks the socket to see if there's a waiting packet for an incoming request. And so what we're watching is this like daemon that's attached to port 80 and 443. We can Control-C and scroll back and look at what it says, right? But so it's waiting for a while, and it turns out the wait system call, you specify a number of seconds that you want it to not run, right? That it's going to wait. And then when it wakes up from that wait, it goes and checks to see if there's something for it to do. So that's why it's in this wait cycle. It wakes up and checks to see if there's any incoming connections on the network that it needs to handle and pass off to the worker daemons. And if there's not, it goes back to sleep and waits again, and then wakes up and checks. All right, so if you were having a process that was misbehaving, you can attach strace to it and see what's happening.
Oh.
Here I'm using both the count and the process attachment. -C says, don't actually show me all the things it's doing.
Just does the counts. You just showed before, yeah.
Right. And what I'm hoping is if I control C when I'm done with my sample period, there it is. It actually comes back and says, this is what it did while I was running. So instead of having to watch all that data scroll by, you can have it capture the data and then give you this kind of synopsis report to see if you really want to go back and watch it run, right? But just like before, we can, this syscall column at the very end of the line, there's a man page for all of them. So we can use man to kind of figure out what's happening during this and like, is it okay that it's spending 62% of its time selecting or 11% of its time waiting? And so we can kind of get a better idea of what's happening there. So that's my preferred underutilized utility in Linux is strace. Not enough people know about it. Not enough people use it. So go forth and use strace.